Now we're moving on to our next speaker, Petar Poznic, who is a data scientist in Enetel Solutions and has 5 years of experience in web development and 3 years of experience in accounting and financial analysis. His talk will elaborate a bit more on how we build a personalized recommender system from scratch in the domain of e-commerce, the challenges he faced, technologies, machine learning models applied, and of course, all the lessons learned from it. So I do hope you're going to enjoy his talk.
Okay. Hello, thank you for coming. Today, I will talk about challenges of building a personalized recommender system in e-commerce. Firstly, I will start with my colleagues that I'm working with, and they're probably one of the smartest people I ever worked, and probably their way tackling of problems is something I'm mostly impressed with. Okay, let's start. Since we were born, we were faced with recommenders, and our first recommender systems were our parents. And they knew what is the best fit for us, what to eat, what to wear. And since then, we are listening recommendations from people all around us, and we are recommending stuff to the other people. But during time, our taste become more personalized, and we tend to listen recommendations from people who we believe has a good taste, or who has taste similar to ours. And we are recommending almost anything: books, movies, food, laptops, watches, cars, you name it. And let's start with the question, why do we actually need recommender systems? Let's first think about concept of traditional stores. An example of a bookstore. We can see here we have a limited number of books which can fit in a physical store, and the popular books will be placed in the center of the store. But also we have a large number of niche books, niche products, which are not so visible to people who are interested in them. And sellers usually choose to put those popular books in the center of the store or at the website, at the home page. And we call that phenomena long tail phenomena. And this is where recommender systems takes place. The goal of recommender system is to identify products that is the most relevant to the users. Like, imagine you enter in the store and you find in front of you products you really need. And some products that you actually didn't know exist, or you didn't know about them, but they are the best fit for you, and all based on your needs and preferences. And we have some examples in the business. We have some large companies that we can say now they use recommender systems for decades. One of the most famous, and probably most famous, is Amazon. They started as an online bookstore, and now they are selling almost anything. And we can see here that 35% of Amazon revenue is generated by their recommender engine. And when you scale it to Amazon revenue, those are billions of dollars. And of course, we have a Netflix, very famous streaming website, and they are well known for because they recognized importance of recommender systems when they were not so popular, when they were not so well known. In 2006, they gave a prize of $1 million to those who will help them to improve their recommendations for just 10%. And when you give such a big prize, you have those numbers competitions of 40,000 teams from 186 countries, and we got one winner, and they got the prize. And now, since then, since 2009, 9 years later, Netflix is a company worth $130 billion. Also, we have other companies like Facebook or YouTube or many others. But there's one common thing for all of them, and that is data. And a lot of data and a lot of quality data, and they're very good at collecting the data for a very long period of time. And that was our first challenge when we started. We have a data for the previous 6 months. And also, we didn't have all metrics we needed, but during time, we also started collecting the data we needed, so we can use them in the future to improve our recommendations. And at the end, we can conclude that if you want a good product, you really need to have a quality data, and as Charles Babbage said, garbage in, garbage out. And when we started to create recommender systems, we were faced with two models that they are most popular, and we use them both. And first, I will start with content-based filtering model. And let's see really basic example how content-based filtering works. As we can see, we have 4 really different product, and content-based filtering actually relies on the properties of the product. As we have here, you have a diagonal of the screen. What is the price? Is it LED screen? Is it smart TV? And you can have hundreds and thousands those features. And what we will do here to see what features those products has and which features doesn't. And we have something like that. And okay, we are at the page of this product. And what we want to do, we want to find the most similar product to it, so we can recommend it later. And what we will do, we will compare how many features they have, how many identical features they have with other products. And okay, we compare it with the first one, and we saw we have a 2. They are both LED, they are both smart, but the other one is probably more expensive and maybe have a wider screen. The second one has 3 in common, and that high dryer have just 1, and it's just price range. And what we will do here, we will probably say that the most similar product to this TV is this one. And this is what we have made on the Technomania website. When you are at the page of the product, you have the most similar product to this one. And this really improves conversion rate. The other one, which was more complicated model, is collaborative filtering. I'm sorry. And collaborative filtering doesn't rely on product properties like content-based. It relies on the ratings. And firstly, we have 2 types of ratings. We have explicit ratings, and we are very familiar with them on the other website, like 5-star ratings we have on Amazon. Likes or dislikes, we can find that at Netflix, they prefer that one, or from 1 to 10 at Internet Movie Database. But they're all different form of the same thing. The other one we want to talk about is the implicit ratings. The data ratings that users don't give us like that when we ask them, can you rate that product? No, we analyze their behavior of the website. We analyze their interactions with products, and what you can look here is how many times did they view some products? Did they bought them? Does they have that product on the wish list, and etc. How many times? What is the duration of time they spend on that product? And also, I'll give you some example using collaborative filtering. As you can see, we here don't have properties of the product, we have names. We have users who has interactions with that product. And now we can have some data that we can see who likes some product and who don't. The next thing what we do is okay, we have a new user who came to this website, and he probably bought that laptop or visited it many times, so we can be sure that he really likes that one. But we don't have information, does he really like other products? And what we will do here is to find similar users to this one. And okay, he likes laptop, and the best guess we can do is to see who also liked that product. And we get something like that. The next thing we will do, we have some voting system like that, and we can see that the most relevant product we can recommend to this person based on buying or liking that one is that phone. And let's see the similar example, but from the different viewpoint. We have two users which we can see they really have similar taste. They like same product, and they don't like the same product. But there are two products we can see here that one user liked, and we don't have information about the other one. And what we will do, we will take the other one and recommend to the other user. Of course, when you are working with collaborative filtering, you always have a cold start problem. So you need a lot of data so you can make a good prediction. So while you are getting data, your model is becoming even better and better. But in the real time, with the real data, those examples are not so simple. It's a bit complicated because you have on the one side hundreds of thousands, maybe you can have millions of users, and here you can have tens of thousands of products, and you have extremely large matrix. And it's very sparse. You have a lot of blank places, and what you have to get from this data to fill those blank spaces. Something like that one, and to take the best rated and to recommend those. And for that we are using ILS algorithm, which is called alternate least square, and use a matrix factorization. What LS is actually doing here, it will take a matrix matrix R and factor it into two smaller matrices U and P, where if they are multiplied back together, they get approximation of matrix R. And the way ILS decides what value to put into U and P is by first filling them with the random numbers. Then it's calculating error using this error formula, and then alternating back and forth between U and P. ILS adjusts matrices, decreasing error, and when error is minimized, he multiplied U and P, and you get this as is shown, and we got recommendations. And this is in the production what we have created. Actually, we just have in productions for test users because we are in the test phase, but I got information yesterday that probably next week the recommender will be live for all users because people from Technomania are satisfied with the results. And also how we did evaluate does this recommender works as it should be. The most recommended method is A/B testing. So you can create two different sliders. The first one will be manually filled with the people who work in the industry, who work for the company, and they did this in their old-fashioned way. And the other users will get the personalized recommender. And we then compare click rate, which we can see that with looking at our analytics, we saw that the recommender is much better doing here, and this leads to a higher conversion rate. So we have a clear winner. And of course, I would like to mention the tools we used. And actually, this is all what we tried when we are experimenting with creating models, and some of people from our team prefer R, some Python, but at the end, the pipeline consists just of these four. And for the future work, we would like, of course, to improve current recommender. And the next project we are focused is personalized newsletters. And I will like to show you some example of this. I don't know, have you heard of a book depository website? They are a web store who sells books, and they have millions of books. So it's almost impossible to know all books they have there. And actually, this is a recommendation of books they send to me. And they write here that is personalized. And then when I looked at those books, there were really subjects that I like, some physics, math, science, etc. And what I did, I decided to look at those books and to read some reviews. Are they good? And then I ordered this one. So this recommender worked for them. But that's not the end of the story. When you go to the page of this book, you have recommendations of many similar books, like I show you with content-based filtering, and then I ordered this book. And this is actually the power of recommendation systems and how they work. And if you have any questions, feel free to ask. Also, if you have any recommendations. And thank you.
I can assure you that definitely felt free to ask. So we have some questions here, and then do keep them coming as well.
Okay.
So going on a bit more, let's say, what is the one thing you learned during this project?
When you read about data science and what is the most important skills to have in data science, many people probably you will read everywhere that it's communication, and many people don't take that very seriously. And this is something I really learned during communications with business department, and this is skill I think I improved. And if you want to work data science, I think that is really something you need to have.
Thank you. And now you said here content-based filtering versus collaborative filtering.
Yes.
So what are the pros of content-based filtering? Pros and cons.
If you are working with collaborative filtering, you before you create a model, you need to collect a lot of data. But with the content-based filtering, you can start working immediately, just knowing properties of the product. But the best thing you can do is to combine both of them and to put them on the different places, like we did it.
You just mentioned here that you need a lot of data for collaborative filtering to be gathered beforehand. So what is the minimum required volume of behavior data for collaborative filtering?
Well, in our case, I think we can work with 6 months or 1 year of data, but it depends on many things. You can give really exact number on that. But as times goes on, your model will be better and better. But you cannot give the line and say, hey, this is enough, and everything before is not.
Yes, it's more.
It's not white and black. It's always some gray line.
Yeah, it's more of a flexible thing than we can say. Than rather that. Going on a bit regarding recommendations, I have a question here saying, have you tried tensor factorization techniques?
I think we didn't. We just from different models we tried clustering, but it didn't work as we hoped.
And sticking with the technologies here, what is your technology stack for the recommendation system?
What is?
The technology stack.
I think I have a slide about that. This is our pipeline. And we work with Python. Actually, it's a PySpark on Spark, which is on Hadoop. And as an interpreter, we use Zeppelin.
Thank you. Going on a bit of a business side of things, does your recommender system actually boost revenue? Maybe ordering by purchase rate multiplied by price would work better.
It boosts conversion rate, but we don't have data about revenue. We don't know that. Actually, the task we got is to increase conversion rate.
So speaking here of profit, is a profit margin for a single product a variable you use in your recommendation system?
Is it?
So a profit margin for a single product, is it a variable that you use in your recommendation system?
No, we didn't use that. We actually currently don't have profit margins for data views.
And how did you choose the number of dimensions in the latent space?
By experimenting, tries and errors, a lot of it.
Always a good thing. And how did you handle large matrices in your production?
No, using Spark, and to finish some model, we sometimes need almost a day, and the Zeppelin is not always stable, so sometimes you start executing model one day and come tomorrow to work and see that something's break in the meantime, so you have start again, and it's not the happiest solution.
Thank you. And sticking here, have you tried to aggregate the products to tackle the scarcity problem?
Not yet. We are planning to do that.
Okay. And of course, you have a data scientist career, and here's a bit more on your question as well. So what is your biggest satisfactory moment during your data scientist career so far, let's say?
When you finish the product, because it takes a lot of effort, and you work really hard, and when you get some results, I think that's something that is the most satisfying when you are working with data science projects.
Quite understandable. And now switching gears a bit, and we all know we all sometimes get a bit hesitant with buying online,
Yeah.
and so does adding product in the bucket actually change recommendations? So does adding products in the bucket rather than actually buying them change any recommendations?
Well, of course, this is some of parameters that can affect implicit ratings I talked about.
And what do you think about Scala plus Spark and how recommendation system works in the production?
Actually, we had a training with Spark, and the training were in Scala, and I really liked Scala, but our pipeline is in PySpark, and I think that if you are working with Python, actually PySpark or Scala, the performance is the same.
And here to cap things off, I assume you're dealing with a lot of data here. And what is that? Do you have any ideas at the volume of data you worked with during this project? And how did you deal with it? How did you handle it?
No, it's data for 1 year of typical e-commerce website, a lot of logs, a lot of I mean, it's some tens of millions of lines. And how we deal it using those technologies.
Okay, thank you. And with that, and considering I don't have any further questions, I would like to thank you for attending this conference, for giving a speech here. And on behalf of the conference, I would like to give you the certificate of appreciation.
Thank you. Yeah. Okay.